In this program, we have three threads that execute concurrently. As you can see, there are three POSIX semaphores that regulates the execution, so the possible execution order of some statement of code. So here A, B, F, G represents a function, a piece of code that is executed. So the idea of this exercise is given these three semaphores initialized in this way and given these three threads that execute concurrently, say which is the possible execution order of this piece of code. Okay, so as you can see, we have three semaphores. Semaphore 1 is initialized to the value 2, instead the other two semaphores are initialized to the value 0. At the beginning, all the three threads are placed on the ready queue, and depending, remember, on the decision of the scheduler, they are scheduled or not. So the scheduler decides which of these threads can make use of your CPU. So in particular, in any case, here the scheduler can decide to start with, for instance, thread 3, but as you can see, if thread 3 is scheduled, the first instruction is this same weight on semaphore 3, but since semaphore 3 is equal to 0, this thread is blocked here. And the same for thread 2. So the only thread that can proceed is thread 1 that perform this same weight. Since semaphore S1 is equal to 2, this value is reduced of 1 unit, and this weight is not blocking. Then code A is executed, so the first code that is executed is code A. Then the execution proceed. This second semaphore weight is not blocking because semaphore 1 is equal to 1, and the action of this same weight is to decrease semaphore 1 of 1 unit. Then code B is executed. Then I have this same post. So here I have two possibilities. The first possibility is that thread 2 is not executed, so this same post increase the value of semaphore 2 to 1, and then in the future, when the scheduler decides to provide the CPU to thread 2, this same weight is not blocking because semaphore 2 is equal to 1. Otherwise, other possibility, my thread 2 is blocked here on this same weight, like this thread 3. When this signal arrives, unblock the thread that is blocked here. Then thread 1 can execute this same weight and it remains blocked by this same weight, or can be descheduled by the scheduler. In any case, thread 2 starts its execution, executes code C, and then there is this semaphore post in here. Here we have two possibilities. The first possibility is that, so street number 1, is that this same post unblock the thread 3 that is blocked on this semaphore. Okay, I have a thread blocked on this semaphore, I have a same post, and the same post unblock it. Second possibility, the thread 3 is not blocked on this same weight, so the same post increase the value of the semaphore S3 to the value 1, and then when thread 2 executes, it is not blocked by this same weight. So the second possible path is this one highlighted in red color. So following the blue path, after thread 3 is unblocked, there is the execution of this code that I named P. Then there is this Semaphores semaphore 1. This Semaphores semaphore 1 unblock thread 1. After this Semaphores, thread 3 finish its execution, so it is not present in our program. Then thread 1 is unblocked, it executes code F here, then it performs a post on semaphore S3. Now the only thread that can be unblocked is thread 2, because thread 3 finished its execution. There is the execution of code E. Then there is this Semaphore that unblock this thread 1 that is blocked in this semaphore S1. Again, the other possibility is that this Semaphore increase the value of the semaphore S1 to 1, and then when in the future the scheduler decides to provide the CPU to thread 1, no problem, because this wait is not blocking. But at the end, the effect of this Semaphore is to permits to thread 1 to proceed its execution and to execute code number G. In the other path, the one in red, after this Semaphore, there is this wait that is not blocking because S3 is equal to 1. There is the execution of the code E. In the second path, there is the execution of code E. Then there is the execution of this Semaphore on semaphore 1, that, similar as in the blue paths, unblock thread 1. Thread 1 execute code F, then execute this Semaphore S3 that now unblock thread 3. Thread 3 is unblocked and thread 1 will be blocked by this same wait. Thread 3 execute code P, execute this Semaphore that unblock thread 1 that finally execute code G. So as you can see, given the same code, depending on the decision of your scheduler, I have two possible execution sequence, A, B, C, P, F, E, G, and A, B, C, E, F, P, G. They have not the same probability, so in some case one execution order is more probable than the other case, but in any case, if you try to execute many times this program, you will see that this program is not deterministic.